Are you interested in increasing the usage of alternative fuels at the main burner, knowing about the impact of main burner flame shape on quality, finding the optimal setting after fuel quality changes faster, analyzing fuel impact on clinker quality, reducing the energy costs? If you answered yes to one of those questions, have a look at Powitec's Thermography, PiT Indicators SideView. With more than 100 installed PiT indicators, Powitec Thermography is at the forefront of flame monitoring in cement and lime kilns. The classical thermography from the front optimally analyzes flame diameter, sintering zone, and clinker bed. The additional video image enables the operator to be aware of the texture of the clinker and the clinker discharge area. With the new SideView thermography, it is possible to precisely analyze plumb length, ignition point, flame diameter, and main flame combustion zone. This makes it possible to discover new correlations between alternative fuels and clinker quality. The SideView thermography is mounted at the kiln head side with an optimized viewing angle to see the burner tip and as much flame as possible. The sensor uses an air or water-cooled rigid endoscope with optical output to a digital camera, acquiring 25 pictures per second, each with a high resolution. To protect the sensor against damages in case of cooling media failures, it is equipped with a retraction unit. These are typical images which can be produced by the PiT indicator SideView. On the left-hand side you see a thermography, and on the right-hand side you see a video image. If you're not familiar with a thermography and polylines, please have a look at the movie introducing the PiT indicator. The thermography shows 6 polylines, 3 horizontal and 3 vertical. The horizontal are showing a plumb function. This is indicating the ignition point of the fuel. The starting point is at the end of the burner. The vertical polylines are showing the flame width. The starting points are both ends of the polylines. In the video you clearly can see the differences between different fuels like coal, animal meal or solvents. Let's now focus on the polyline showing the ignition behavior of animal meal. Changes in the igniting are clearly represented as ignition point signal value. This is what we call plumb function. There is a clear reflection in the polyline. If you see on the left-hand side, the igniting point in the first half of the picture was far away from the burner and in the second half went nearer to the burner. This is clearly reflected in the polylines. Let's have a look at another thermography. On the top and the left side you see the status of several signals, for example the temperature of the sensor tip. This is indicated as a traffic light, so it will be changing to yellow or red if the temperature goes over a certain level. You as well see the thermography with the temperatures indicating and 2 polylines over 3 hours recording the temperature distribution alongside the polyline. The temperature recording from the different regions of interest, which are drawn into the picture as squares, are shown in the lower left side. And the most interesting in this screenshot might be these 2 areas. What you can see here is on the left side the operator increased the fuel feed, which is indicated as a red line in the polyline and red from the DCS via interface. So the operator increased the fuel, but there was no temperature reaction. This is clearly shown by the polylines. Later on, he increased the fuel feed and the flame really explodes. And he almost took the same level of fuel feed increase, so there is a clear indication that there is a different fuel property, which you only can see from the polyline. This is how the PiT